All right. Good morning. Hope you're all doing well. I'm actually using a new laptop today. Can you guys just let me know? We had some problems first period. Can you guys hear me and see me?
Yeah.
Yeah? Okay. Okay, good. All right. So today I want to finish up with lesson 7.2 and then let you spend some time in the teams working on these problems that are challenging. You have systems of equations in three variables. They're a lot of work. If you notice that I only assigned problems 1 through 12, I didn't assign all the problems for that reason. So what I want to do is I also assigned problems 23 and 24. So I want to do problem number 24 together, and then we'll go into our math wizard teams. Do you guys want to ask me any questions though before we get started? Anybody want to ask me any questions about anything? All right, I'm on page 829. So page 829, number 24. So if you can write it down and work it with me, please. Page 829. Now, like I've said before, when you work story problems, it's not like English where you get a feeling about a character, you get a feeling about the story. It's real technical. Like words mean things, like is means equals. Sum means add, difference means subtract. And so let's read through this problem and see if we can set up a system in three variables. Okay, can you guys see my board okay?
Kinda, yeah.
Yeah, it's just that your sound is like low. I'm not sure if it's just me.
Okay. Um, my sound. Let me see if this helps. Okay, does this help? Can you hear me better?
It's kind of the same.
Yeah.
Okay. All right. So, like I said, I'm not using my laptop. This is something's wrong with my laptop, and so they're trying to fix it. And this is a loaner from the school. Okay. So here we go with problem number 24. So it says the following is known about three numbers. 3 times the first number plus the second number plus twice the third number is 5. Now, we don't know the three numbers, so we're going to use X, Y, and Z. So X is going to be the first number. Y is going to be the second number they're talking about, and Z is the third number. Okay, so let's read it again. It says the sum of three numbers. Sorry, I'm reading the wrong one. 24. 3 times the first number. So 3 times the first number would be that. So 3 times the first number plus the second number plus twice the third number. Now, twice the third number means multiply. So that would be 2z. So this represents 3 times the first number plus the second number plus twice the third number. Okay, let's continue on. And that equals 5. And it says if 3 times the second number subtracted from the sum of the first number and 3 times the third number. Okay, so this being subtracted. So it says if 3 times the second number is subtracted from the sum of the first number and 3 times the third number. So does that make sense? If this guy is subtracted from the sum of the first number and 3 times the third number, the result is 2. And we have one more to set up. If the third number is subtracted from. So if the third number is subtracted from 2 times the first number and 3 times the second number, the result is 1. So does that make sense? If the third number is subtracted from the first number, 2 times the first number, and 3 times the second number, and the result's 1. Okay, now, since these problems are so long to do, what I'm going to do is I just want to make sure that we set this up correctly. So this is problem number 24, and you're going to be doing number 23 and 24 in your lesson. I just want to make sure I set it up right. So the first one is 3x plus y plus 2z equals 5. This is x minus 3y plus 3z. So I'm going to switch the order. Remember, the order doesn't matter. So you do realize that if we switch the order, it doesn't matter. So I can make this negative 3y plus 3z. So I'm going to do that just so the variables are lined up. So it is correct the way we did it. We're just going to switch it so the variables are lined up. Minus 3y plus 3z equals 2. And 2x plus 3y minus equals 1. So we did set it up correctly. By the way, I want to congratulate you guys on your last exam. A lot of you did really, really well on it, and I'm really proud of you, and I wanted you to know that. So good job on that last exam. All right, here we go. Now, remember what I said when I taught this. I said you want to pair up equations. So you need 2 pairs. So let's look at this for a second and see, do we want to eliminate x, y, or z? And can you see that y is probably going to be the easiest? So what I'm going to do is reuse this guy. And we're going to eliminate y. So here we go. So we have 3x plus y plus 2z equals 5. And we have the second one, which is minus 3y plus 3z equals 2. So that's one pair. The next pair is the second one, x minus 3y plus 3z is equal to 2. And 2x plus 3y minus z equals 1. So do you see why I chose to eliminate y? Because it already disappeared there. And on the one on the left, I just have to multiply the top one by -3 to get true opposites. So I'm going to multiply the top by 3 and rewrite this. So remember to distribute. We have 9x plus 3y plus 6z equals 15. And on the bottom, you have x minus 3y plus 3z equals 2. So we eliminated the y by adding. All right, so let's work with this one first. So when you add 9 plus 1 is 10x, 6 plus 3 is 9z is equal to 17. So that's one of our equations in 2 variables. The other one is 2 plus 1 is 3x. 3 minus 1 is 2z equals 3. So remember, you're adding. Now, remember what I said. You have to eliminate. It doesn't matter what variable you eliminate, but it has to be the same variable. So I eliminated a y and I eliminated a y. And the reason why I did that is now I have a system in two variables, 10x plus 9z equals 17, and 3x plus 2z equals 3. So now we decide, do we want to use eliminate, do we want to use addition, or do we want to use substitution? Now, I don't know about you, but these aren't easy to, it's not easy to solve for a variable. So I don't want to use substitution. So, and not only that, but it looks like it's hard to eliminate the x and it's hard to eliminate the z. So a common number with 3 and 10 is 30, and a common number with 9 and 2 is 18. So let's eliminate the z. So what we're going to do is we're going to multiply the top by a -2 to get 18z, negative 18z. And on the bottom, we're going to multiply by 9 because we're trying to eliminate the z. So I'm going to rewrite it. So this is going to be -20 minus 18z equals -34. And on the bottom, we get that's -20x. And on the bottom, we get 27x plus 18z 27. So see how I created that to eliminate? So now we can solve for x. So when you add that, you get a positive 7x, and this is going to be a negative 7. And get x is equal to -1. Okay, now what we're going to do is we're going to substitute back into one of these. I like the second one. So we're going to take 3x plus 2z equals 3 and put a -1 in for x so we can find z. This would be 3 times -1 plus 2z equals 3. -3 plus 2z equals 3. Add 3, it goes away. Add 3, you get 6. So z is equal to 3. And now, if I can find another color marker. Now, to find the last variable, we use one of these. Now, I don't know which one is best, so I'm just going to use the top one. So you have 3x plus y plus 2z equals 5. And so we plug in these variables. We have 3 times -1 plus y, we don't know, plus 2 times 3 equals 5. And now we're going to find y. So -3 plus y plus 6 equals 5. 6 and -3 would be y plus 3 equals 5. Subtract 3, subtract 3. And so now we should, normally with the other, we write an ordered triple, but that doesn't make sense in this problem. They just want to know what the numbers are. So we're going to say the first number is -1. The second number is 2. Third number is, that's our answer. We found the numbers. And this is correct, by the way. Now, there's a couple things that I want you to notice. Notice how I'm keeping my problem in sections, because that eliminates confusion. And if I make a mistake, I can easily go, like I can see that in the black, I have the 2 pairs. In the turquoise, I have the system in 2 variables. In the orange, I'm finding Z. In the red, I'm finding Y. So the way I have the problem set up, it's easy for me to find an error if I made one. The other thing I want you to notice is notice how I'm trying to write really neat. So I'm not making careless mistakes, because careless mistakes in this problem, if you have to keep doing the problem over and over again because you're making mistakes, that could suck up a lot of your time. So we want to try as hard as we can to do the problem correctly the first time. All right, so when you have a system of equations in 3 variables, you're trying to make 2 pairs and create a system in 2 of the same variable, in this case, x and z. Then you solve for x and z, and then you go back to the original to find the 3rd variable. All right, does anybody have any questions? Okay. What we're going to do then is we're going to go to the Math Wizard teams. Class is over at 12:10. We're going to report back to WebEx at 12:05. In case there's anything I need to clear up. And you're going to work in your teams on the assignment. So if somebody's already done problem number 1, don't start with problem number 1. You have to work problems that everyone has not worked. Okay? So whatever problems your team has not worked, those are the ones you're going to work on. And you're going to see if you can solve these. It's like a puzzle. Okay? And hopefully working together, you'll be able to do it. I'm going to be here if you need me, just let me know. But I will see you in your Math Wizard teams. I'll be taking attendance there. All right? Okay, I'll see you in there. I'll see you back here in WebEx at 12:05. All right, so first of all, what I want to say is if you don't always match up or pair up the first, the second, and the second and third. You don't always do that. So what you're pairing up is the easiest pairs to eliminate a variable. So you might pair up the first and the second and the first and the third. Or you might pair up the first and the third and the second and the third. So it doesn't matter which ones you pair up. You're trying to pair up ones that are going to allow you to do the easiest problem. So let's say you start something and it's a big old mess. Don't be afraid to stop and start over and do something else. So don't be afraid to change your mind about the variable you're going to eliminate. Okay? Because if you pick the best variable to eliminate, the problem's going to be easier than if you pick the worst one. So I'm just telling you. And it's not always easy to tell. So if you start a problem and it starts getting complicated or looking really messy, don't be afraid to stop and start over. Okay. So number 5 was a little tricky because if you paired up 1 and 2, you lost x and y, and you're able to solve for z right away. So that's okay. And that problem is actually easier than some of the other problems that I've worked. So anybody want me to work a problem, or anybody want to ask me a question about a problem or get you started on it? All right. I think I made this assignment due. see when I have 7-1. Okay, I know that 7-2 is due on. Seven one was due on the 8th. Okay, so 7-1 was due on the 8th, and 7-2 is due on Wednesday. All right, listen, I hope you have a great day, okay? Have a great day, and I'll see you on Wednesday, okay? Have a good day.